everyone. AI animation keep evolving so fast. We dive into the mesmerizing realm of Rave technology, an innovative approach that brings text-based editing to new heights. Imagine effortlessly creating visually stunning videos by simply typing a few words. With Rave, the magic happens before your eyes. Join us as we explore the capabilities of Rave, from its revolutionary noise shuffling technique to its ability to maintain seamless consistency in your edits. Discover how to enhance attributes and reshape scenes to unlock a realm of creative possibilities. But that's not all. Rave takes it a step further by enhancing the power of stable diffusion animation from AnimateDiff, creating breathtaking visuals that captivate your audience. Are you ready to embark on a journey that will forever change the way you edit videos? Then let's dive into the enchanting world of Rave technology and unleash the magic together. This is our long video. I am going through a very detail of Rave technology. I am trying to bring technical terms and words rephrase to be easier for artists and non-technical people can understand. Before that, please hit that like button to support me to create a longer detailed tutorial like this. And subscribe our channel if you haven't done yet. Let's start cooking. So let's take a look. What is Rave? So Rave is what they call randomized noise shuffling for fast and consistent video editing. And that is with the diffusion models. Now, as we are very familiar with stable diffusions, and yes, this is based on stable diffusions 1.5 models. And check this out. Their demonstration on here, you can see the train, you can see the wolf, can see the car just like that. And basically, you can use a text prompt like this guy he's typing, and then you change the style of the guy to astronaut typing or a skeleton to type. And below that, we have some very technical word in here, the abstract and methodology, how they use this Rave method technology to do processing condition grids and processing the sampling to new videos. And I'm not going to go through all the details of this white paper, but just want to show you on their examples here so you will get easier to understand rather than I throw all the technical terms. So below that, we can see again that man's typing, the wolf transferred to dinosaur and a black panther, and also a shiny robotic wolf. And they are just capturing the motions of an object in a video and turn the objects into another form with using the same motions. So like this one, I guess you guys will like it because they can also do like people's characters, which stable diffusions are very specialized on making characters in enhancing more details. And right now, this models, this technology's Rave, they can transform a girl doing exercise, stretching, and turn it to a firefighter. You can take a look at all this, and then it turned to watercolor style, and then it turns to zombie style. And yeah, it's just based on your imagination. You type a text prompt, how you want to change the motions. And like I said, it is not only for characters, it can also do it for any elements, any objects like a car, and you can transform to a truck or a train or a fire truck, and the backgrounds also could be changed. While that will be not too much background change, but the style and themes can be changed. And below that, we have some comparison. From their page here, you can see different styles, how they go. And here's some example of the data set. And if you are interested in more technical side of this, and you can check this out. Yeah, and it's really cool. And this thing, let's take in action. Oh, we got to do it in ComfyUI. So when reloading ComfyUI, let's clean up the workflow. And we are going to bring in the workflow, the basic workflow from their GitHub page. This is a very basic workflow. And by the way, I have not installed the Rave ComfyUI custom note yet. I want to install this together in this demonstration. You see these all red colors. So basically they need the ComfyUI noise and ComfyUI Rave custom note. So you can download in here manually. Just go to ComfyUI noise and you can download this zip file manually in this green button, or you can download it in ComfyUI Manager. That would be more manageable in the file terms of how we dealing with all the messy files. So let's download in ComfyUI Manager. By doing this, we click on Manager, we click on Install Missing Custom Nodes here. So the ComfyUI will fire up and detect what is missing in this workflow. And there we have two custom nodes here that we have to download. So the ComfyUI Noise and ComfyUI Rave, these two custom nodes, we have to install them each by each. And just click the install button and wait for one finish. And then I'm going to install the ComfyUI Rave again. Click the install button and both of them are installed. So we have to restart the ComfyUI in here. So when we restart the ComfyUI and the page reloaded, and we will see these two red custom nodes are gone and it become complete custom workflow that is running for Rave. So first of all, we have to check each of this. So this is a very basic workflow that is running Rave. And first, we are loading a checkpoint on here. So again, I'm using the realistic visions, and as you can see here, we got the text prompt for positive and negative. And you see, this is very basic. They are just typing a very basic text prompt here. You don't need to be so complex and overwhelming with all the long form text prompt. And then it goes to the control net. Now, this is a very important part. But when you're using the Rave technologies, because you need depth map control net to pre-processing, and then inject the control net into your sampling step. And right in here, we have applied control net nodes for receiving the positive and negative prompts, the vision clips as well. And then we have the Zoe depth map pre-processors. So when we fire up this workflow, it will be first collecting all the image prompts. All the image frames from the videos go to Zoe map preprocessors. And then once it's done, it will pass to the control net. So here's the load videos custom node. And this is very common that we use in AnimateDiff video to videos. And let's check it out. I have some videos here and maybe one of the iconic dance videos that I did before, which is this one from a very famous dancer. And let's check it out here. So below that one, we have another control net that will be for unsampling. But before that, let's lower the frame cap. So for demo purpose, I'm going to do, let's say, 60 frame caps. I think that will be enough for like a second and a half durations. And after that, we set up this, we can check the one underneath here. This is another applied control net that is for receiving the Zoe depth map image. And then we have the unsampler and the case sampler of Rave. Now this case sampler and the unsampler are specified for running Rave. As you can see, let's scroll up on their white paper. Can see this part, the condition grid and the Rave preprocessing. These two parts are done by the unsampler. And then the grid image, which is they are taking like numbers of image frame. And then it will pass to a sequence here. So the condition grid are going to pass to the Rave video editing. That means in our case here, we have the case sampler Rave. And then after case sampler, it generates to the latent image. And we are using the VAED code. And we will have the image frames pass it to the video combined for processing complete videos. Okay, so let's check out and let's click Q prompt. Let's process it one time with you guys. You will see the result. Now, this text prompt is, I have not changed yet, but it have described like a white color styles. So maybe the kilter dress will change to a white dress or maybe other white color style outfit. So you see the first step, it goes to Zoe depth map, processing all the image frame into a depth map. Pass it to the control net, and then the control net can be identified the objects on each image frames. And right now, the command prompt, as you can see, is processing in the unsampler. So what it does in this part is going to decode each image frame into a denoise pixel, basically. And each denoise image we will pass to a condition grid. And then it goes to the K sampler for Rave. Now, this sampler, I should show the processing of the sampling steps on the next example. But this is what we are going to right now, the Rave video editing. This is where we do, in this case, sampler. Okay, as you can see, we have the grid on here. Okay, so I did turn on the grid, the image preview. So we have the grid showing in the sampler. As you can see, I'm setting the 3 grids per grid size is 3. So it's going to be 3 image on each row, and that will be 9 image frame for each grid. So that means it's 3 by 3. And yes, you can see that the text prompt is very simple. I just got some white cupcakes. But then in our case, our videos, we have a character. So the AI turned the character's outfit to white color. And there's a little detail is difference also in the background. I mean, if we describe more in the text prompt about the backgrounds, and it will eventually change the background as well. Okay, the VAT finished and we have the video combined showing the result. Look at this. Actually, it's kind of flickering because it is using image to image processing for these videos because it's a very basic workflow showing their technologies by Rave in ComfyUI. But then you can see the color of the outfits is changed and the outfit styles of the characters is totally different right now, although it's same as a short dress, but then the characters on here doesn't have the black long boots like this one, and the characters in the result don't have this black sleeve. So yeah, it is quite cool, you see? And if we don't have flickering, and that will be a very consistent and totally change outfit with a very stable, very consistent animations. So how do we do that? Next step, we are going to use an other workflow that I test before, and let's bring another examples here. So let's try another example again with my stock videos here. Is this videos I did for previous dance animations demo. And in this text prompt, I changed to a monkey king with a purple shirt and dancing in a tropical forest in Amazon. So let's try this one with this dance videos of this hip hop guy. And I turned this to 32 frames. So make it shorter. And after this, we will try out how to solve the problems of having a flickering on our video result. But first, I want to test with you guys, how can we just easily using the text prompt and change the character's outfit and even the character itself. Just like their demo page that's showing their white paper and their examples. And this time, I am showing how to change the male dancers into a monkey and wear a purple shirt. And let's wait for the result. I'm going to fast forward the loading process here. And this is really cool technique to integrate with AnimateDiff. And once we finish this rave, changing all the styles with text prompts and the backgrounds, the characters, we can bring the video's result to AnimateDiff and make it so smooth without any flickering. And that will be like another milestones of our AI animations by using stable diffusions and comfy UI. So what I have told in last live talk in open art, and let me show my presentation screen here that I have specified talking about like back then, we are using the movie producers, the movie makers, they are using all this equipment set up in their studios just to make these animations of 3D characters or CGs. You see, this is very familiar, right? This Pirates of Caribbean, and look at the face here. It's very familiar, like the open pose that we use. And then, as you can see in reality, Dan Stevens wore a goofy outfit to play the mean. My prediction is correct. This is happening right now. For the industry that want to use AI, you should take early step. Try this out because you don't need to set up all this equipment and require the artist to wear a goofy outfit to perform some CG characters. And here's the result. There you have it. We have the monkey wear a purple shirt dancing. Well, it's kind of like a tropical forest because it changed all the trees, like Amazon style trees. But then there are still some backgrounds of the buildings it cannot get rid of. But it's okay. And yeah, I have just put everything in the text prompt and look at this one. This is the original source videos from my stock videos footage. And the male character dancing on urban cities like this. And let's take a look at the preview of this. You see the monkey dancing animations here. And yeah, basically this Rave technology is capturing the motions of our source videos. And then it transformed those motions, any movement into other forms of characters or any objects. And that is based on our text prompt. But then one problems of this basic Rave workflow, it did a lot of flickering, as you can see. So our next step is to try to solve these problems. But one thing I want to show you guys as well, because we can also use IP adapter to prompt these styles. Because as you guys know, one pictures can represent 1,000 word. Sometimes you cannot use a text prompt to do a perfect styles that you want. So if you have a reference image like this, you can use IP adapter to connect into the models and run the entire generations using IP adapter as well. So I'm kind of disagree some videos that is talk about Rave previously last week. I saw it and he said basically this Rave technologies can be used only text prompt and without the IP adapter tricks. And actually IP adapter is not a tricks, it is an image prompt. So like one image, again, one image represent 1,000 words. So if we do have a good image for styles, then why not we are using it, right? So I'm kind of showing this one. Just want to demonstrate that we can use IP adapter as well in Rave workflow. So in this example of the IP adapter, I am going to change the text prompt first. Now the text prompt I'm going to emphasize, this is a female and wear robotic armory and dance in the futuristic cities with cyberpunk styles. Now, if you type only the text without IP adapter, it will generate any randomized robotic futuristic styles for your result. But then in my case here, because I want the generate result, is specifically with using this image robotic styles outfit. So you will see the result here that it is going to be almost the same styles as my reference image. Now here's the result. As you can see, the blue and silver armory styles and also the futuristic backgrounds of the cities. This is also following the reference image. Even I type the text prompt. I can run this without the text prompt, but for emphasize it and be more accurate for the AI to generate, I type the text prompt with it and it can be more precise of what I want and what I expected. But then the armory styles is just following my reference image. As you can see here, the blue and silver styles armory, and this is the IP adapters, also work in Rave. It doesn't mean that Rave, we are just using text prompt, and that is done right because image prompt and text prompt are also prompts for in the AI point of view. You are just inputting something to tell what the style you want the AI to generate. And here's my AnimateDiff flicker-free workflow. We have submitted this in OpenR and in our Patreon as well. And this is my current progress of working on this animations workflow. And I think I can integrate this one with the Rave technologies using the AnimateDiff and some control net to stabilize the videos without too much flickering. And hopefully I can eliminate all the flickering in the video's result. So the next step, we are going to integrate this with Animated. Well, I'm not going to just copy the whole thing from my AnimateDiff workflow into here. Instead, I will be taking the part that we need and combine it together. Then our new result will be very consistent on the outfit and the backgrounds that leveraging the Rave technologies. And then we leverage the animated and control net technologies to eliminate the flickering issues. Then our result will be perfect. So after my first test with integrating AnimateDiff together, And this is the result. As you see, the left one is the Rave result, and then the right one is the one that I display after ref goes to AnimateDiff and process in AnimateDiff to this result. So you see both belly dance. The right one is more stable, but there's still some flickering because I have not applied any control net on this. And this is the source videos. As you see, the outfit of the source videos is totally different. It's black colors, and then the hairs and the leg is totally different with the belly dance. And as you can see, the belly dancer in these animations, the shoes and the legging is totally not the same as the source video. And it doesn't got any influence by the source videos that we used to have in AnimateDiff. Sometimes you cannot get rid of some control net line art influence, and it caused some kind of like clothing shadows behind because the source videos is not in that dress. And in Rave technology, we can totally eliminate that. And then, yeah. So we are going to try out the new workflow that is combining AnimateDiff with Rave. So here's the current versions of the AnimateDiff Flickr free workflow that I upload in Patreon and OpenArt, and I have labeled this one. So it's clearly understand for people not mixing up with another workflow for Rave with AnimateDiff. And currently I have make this one into Rave plus animated free workflow. So this is the new layout, new workflow files with using AnimateDiff and Rave. And the Rave initial loader on here, as you can see, is also able to use the LCM. And I put add detailers in the LoRa's model. So add some details to enhance the image quality. Now, the difference of this is that you can just load the checkpoint models, and then you are using the text prompt to change the styles in this animations workflow. So in here, I put women wear bikinis dancing beside swimming pool, Hawaii beach background, something like that. And then I have two control net on the front, which is the depth map and the animate control net checkpoint. Now, I will post the link in my website, post articles, and you can download this checkpoint models as well. So going on the left here, we have the get mask character image and the set initial size image. Now, typically I saw people are loading videos and resize image and pass those image into the Zoe Math preprocessors for ControlNet. But then in this case, I have my videos here. As you can see, there's a lot of backgrounds, and I want to get rid of those backgrounds. The depth map, even using the depth map here, without using the line art, there are still backgrounds elements that will influence our result. So I'm using my existing segmentation mask from my previous workflow for AnimateDiff. This is exactly the same one. And I'm using these groups of segmentation masks and move that to my Rave animated workflow here. So as you can see, both are exactly the same one. So that's why the benefit of making things modularity is good, that I can move around on even difference workflow. So back to here, we have the control net and then the animate control net checkpoint. That is for enhancing the animations on each image frames. And then put the character's movement and everything, the motions into smoother way to present. And then we have the seat numbers. As you can see, this is a global seat number settings that you can connect these seat numbers, or you don't want to use the same seat numbers, you can use your own seat numbers. And then the width and height here you can set on here, and it will apply to all these videos, image frames on all the workflows. So go to the first step. We see these groups, the Rave groups. Now I got inspired by other guy in Discord that using this sampler custom to do the Rave unsampling, instead of just using the simple unsampling custom notes, we are using the sampler custom here. So we pass the initial Rave latent data into the latent image in this sample simpler custom note, which is from here. You see this one. Yes. And then we go to the latent image, and then we pass into the fixed seat numbers here. CGF, just use one. It's good enough. And then we use a case sampler, select which I'm using the DDIM, and then the basic scheduler, I'm using the normal one. So it will be transformed from the DDIM into the normal scheduler. That is going to be handled easier to handle by the LCM in later steps. So because we are using the LCM here and our case sampler are also going to be select the LCM sampling method, and the scheduler are going to be using normal. So in here, the case sampler for Rave, we finish it and pass the VA decode, and we got the Rave video latent. And then, yeah, before the video latent, we have to do a VA encode first, and then we got the latent data. And here's the example of we are using the Rave, only the Rave output. Now, as you can see, the first steps in here to generate result from Rave is still flickering a lot, but you can see the outfit and the backgrounds of it is totally changed. Well, I mean the background, there's still the building influenced by the source videos, but then we have the characters that is totally changed from a black dress, long height, boots, into just a bikini look in the Hawaiian styles. Then this is the first result from Rave. So after via decode, pass it to the video combined and make it to videos. But then we want to enhance this. So we have to pass the VEG encode goes to the second step. Okay, so the VEG encode on here we are getting from the image frames, pass it to the video latent of the Rave. And then we are receiving the Rave video latent. And then this is the second group. The second group is for AnimateDiff, and here we are going to enhance the video images to a smoother motions. You have non-flickering motions in this result. So what we do in here is in this case sampler, we are going to process the Rave video latent. But before that, we are receiving the stable diffusions model from our loader groups. We pass to the free UV2, and then we are going to rescale our CFG to 0.7 down a little bit using the multiplier, and then we are passing that models to our case sampler for processing each image frame to our to process our element diff image frames here. So this is how we are going to enhance the second step of the videos with AnimateDiff. And then here is the result of the new dance animations. Now, as you can see, the color is sharp, more brighter than the first result from Rave. And then we have below on the set notes here, we will pass the animated video, one image, and also the video one latent data. So we are going to moving on into the detailer on next steps. But then in these steps already, the videos is already enhanced. The process of this in here is already making the image color more brighter. And the motion of the character are smoother than just only using Rave. So let's resume the preview here. As you can see, the character dancing beside the swimming pool and in the source video. We don't have a swimming pool on the floor like that, right? So let's go move that side by side compared with the Rave first. So you see the Rave result is flickering a lot, and the color is kind of not bright, and H characters is not sharp. So we enhance that one with AnimateDiff. And there's more detail of it because we process more sampling steps in this group as well. So we got the swimming pool and also the building. And the glass mirror of the building is more clear. Now, this is the third step. We are going to move that to the detailer, which is exactly the same detailer as we have in Animate Figure Free workflow. And then we pass the video latent into the detailers receiving the VD code here. And then we are processing the whole thing again in here. But then in this detailer, I'm not only processing the face detail, I'm processing the whole person, the character's detail. So I want the whole movement of the character to be more smoother and become more enhanced on the colors, overall, everything thing. And then I pass this to the reactor groups here. So we did face swap on this node. And as you can see, the character's face is transformed into my reference image character's face. And then lastly, we are going to the main output, which is doing the upscales of overall these videos from the face swap result. Yeah, just set that one into the get face swap result. And then we are using the 4x ultra sharp upscale models. And then lastly, we are going to refine the image, each image frames on these notes. So the frames are going to be more better, more enhanced. And then lastly, it's going to, show in the videos combined on here, just like what you just watched in the beginning of this video. We have the one that is high definition. Well, it's almost 4K, but it was kind of not really go to the 4K resolutions yet. So yeah, this is overall of this workflow that I'm going to save this one. I will post that in our Patreon group for our supporters early access. To test this, run this. You can just use the image no text prompt to transform your videos into another videos. But then, unlike my animated freaker free workflow, and as you can see, my previous workflow that I did is leveraging the IP adapter for characters and then for the backgrounds. Now, this one, as I'm showing on here, this is another workflow that I have integrated the IP adapter into the Rave plus AnimateDiff workflow, and it's already working. And both of that can use text prompt and also the IP adapter to change the styles of characters and the backgrounds. Everything on the videos, as you see, as you just saw in the beginning of this video, the characters were beginnings, but the backgrounds of it is totally changed, is in Hawaii Beach and is dancing, and the build of the source videos is totally get rid of. It's totally changed in a sunny beach background. But yeah, in these videos, I'm going to just releasing this basic workflow using text prompt to edit the videos first, because I want you guys to step by step going through and learn how to walk before you run, right? So I know some of you are still not able to understand the concept of IP adapter, but then try with the basic text prompt first, and then we can move to the second step of this workflow. And even this animated fricker free workflow that I did, I changed a lot as well. And the result can be very close to the Rave plus Elementive workflow, except there's a little consistency lacking in the previous element workflow. But in this Rave element workflow that I did just now, we can eliminate the consistency with just text prompt, or even on the next versions, I'm going to release the image prompts. But then both of work, I mean, both can be done with very smooth animations. But then I will just release the text prompt versions first to let you guys understand what is happening and how can we use the technology of Rave and just using text prompt to change your outfit of the characters and the backgrounds of it. Then next videos, next update, I will release the complete versions of this Rave Plus animated workflow that is including LCM and IP adapter. And also the detailers are going to be upscale as well for your animations result. So I hope you guys like this update and like this new workflow and try it out for my Patreon supporters. You guys will like it because I know lots of you have asked me about how can I easily change a more simple way to change the character's outfit with just a text prompt. And now there you have it. And this Rave technologies can also improve the character styles to be more realistic styles. You see all the skin and colors of it, because why I'm going to use beginning in Hawaiian Beach this time for the sample, because I want to show you guys that it actually can transform the characters almost like a realistic characters. So I hope you guys like it. If you do not understand something, you can ask me in Patreon groups, and if you still not understand of some part, rewatch these videos again and see what is going on with the Rave technologies. So I will see you guys in the next videos and enjoy it. Goodbye.